Now question number D says the following. For the given utility function, this was the utility function that was given to you. The next question says, write down the first order conditions for this problem with respect to x1, x2 and lambda. Let's write down the problems. So del L by del x1, you differentiate this function with respect to x1, gives you alpha x1 minus r1 to the power alpha minus 1 into x2 to the power beta plus lambda. M is a constant, its differentiation will be 0. P1 is a constant. So P1 into x1 with respect to x1 will be minus P1 is equal to 0. I can solve this and rewrite this as alpha into x2 to the power beta upon x1 minus r1 to the power 1 minus alpha is equal to lambda P1. This becomes my first equation. Now let's write down the second equation. So del L by del x2, you differentiate this function with respect to x2. So you get beta x2 to the power beta minus 1. And then you get x1 minus r1 to the power alpha plus lambda into minus P2 and you equate it to 0. So you solve for this and you get beta into x1 minus r1 to the power alpha upon x2 to the power 1 minus beta is equal to P2 into lambda. This becomes your second equation. This is equation number 2. At last, you differentiate this function with respect to lambda and solve. So now I'm going to differentiate this function with respect to lambda. And when I differentiate it with respect to lambda, I'm just left up with this, right? Because this all is a constant. So remember, whenever you are doing partial differentiation, you differentiate the function with respect to one variable, holding the other variables constant. So, you know, when you were differentiating with respect to x1, you were holding x2 constant and you were also holding lambda constant. When you were differentiating with respect to x2, you were holding x1 constant and lambda constant. When you're differentiating with respect to lambda, you're holding x1 constant and x2 constant. So this is something which we have to follow. So because x1 and x2 are both constant, this entire term, the differentiation of constant is 0. And this entire term is of course constant, right? This bracket ke andar wala term. So lambda into constant will just be that constant. So when I differentiate with respect to lambda, I get m minus p1 x1 minus p2 x2 is equal to 0, or I get m is equal to p1 x1 plus p2 x2. This becomes my equation 3. So, you know, it had just asked it to write down the first order conditions with respect to x1, x2 and lambda. And we have written the first order conditions with respect to x1, x2 and lambda.